Okay, welcome guys. So today's lesson I want us to discuss the three-dimensional trigonometry. Okay, the three-dimensional trigonometry. We're going to see how this works. uh, when we talk about the three-dimensional trigonometry, it has to do with what we call, let me quickly share this with you, the sine rule, the cos rule, and the area rule. Okay, so this is what we're going to discuss in this lesson. Okay, so now uh, let's say the sine rule in any triangle, we can use what we call the sine rule to find the missing side or the missing angle. We can use what we call the sine rule. So now the sine rule, it goes like this. It says that the sine of angle A over the sine of small a, this is equals to the sine of angle B over small b, which is also equals to the sine of angle C, everything divided by the small c. Right, so when I have it like this, remember we can just write this as A. Is the same if we write it as A, but it will depend on what are we looking for. Okay, so we can write this as A, the angle A, and this is equated to B over the sine of B, and this is equal to C over the sine of C. Right, so the angle opposite to this one, the side that is opposite to that one, let's quickly highlight that partner. You see this sign here, this one, this guy here, this one. Okay, so the side that is opposite to that one, we're going to call it small a, and the side opposite to that B, we're going to call it small b, and the sign opposite to this one, we're going to call it small c. So when I have this, what can I do from here? I'm just gonna check what I don't have, and then we can quickly work on that. You'll see when we do examples, everything will make sense. Okay, now let's look at the cos rule. Remember, in any triangle, we are talking about how we can find the missing sides in any triangle. So now I'm just gonna go straight to the cos rule because these are the topics that we're going to work on now. So look at this. If I say the cos, we have the sine rule, we have the cos rule, and the area rule. So the cos rule goes like this. It says that a squared plus b squared. Let's say we are looking for a. This will be a squared. It will be equals to, so a squared will be equals to a squared is equals to b squared plus b squared plus c squared. Then we're going to subtract 2 bc, the cos of angle A. So most of the time they just give you this formula on your they just give you these formulas on your formula sheet. I think what I need to focus on is how to apply these formulas, when to apply these formulas. I'm not gonna stress on explaining these formulas. Please, no, I'm going to help you how to apply the formulas. What you need to know, make sure that you know these formulas because they will be given on your formula sheet. Then we have this guy here, which is the area rule. So the area rule, look at this now. The area rule, it says that in triangle that ABC, what will be my area rule? We're going to use the one that says half, then A, we're going to multiply that by B, then the sine of angle C. So I need to explain this angle C. What is this angle C? It's very important that you guys understand the angle C partner. Look at this. You see this angle C. This angle C, it must be an included angle. very important. It must be included angle. This is very important. Né? Please make sure that you don't forget that. I'm going to explain what I mean if I say this is included. For example, if I'm given the length of AB, and then I have the length of AC, BC. So the included angle is the angle that is between the two sides that are given. Then we say this is included angle. I hope everyone is happy with that. Okay, so if we keep moving now, I'm just gonna give you a quick notice. Né? I'm just gonna give you a quick notice what you need to keep in mind. I need you guys to know to keep this in mind, that let's say you are working with in a 90 degrees. Remember, if we have a 90 degrees, what do we call that? We call this a right angle. Né? We call it a right. We call this a right angle triangle. So it's going to be a right angle triangle. So in a right angle triangle, listen, we do not use any of these formulas. If you are given a right angle triangle, please do not use any of these formulas assembly, please guys. So if the triangle is a right angle triangle, what I need you to do, if it's a right angle triangle, you know what you need to do. You need to say we're going to use normal. We use normal trig ratios. So we're going to use the normal trig ratios. I'm going to explain what I mean by that. Remember, the normal trig ratios that I'm referring to, it's like saying the sine x is equals to opposite all over hypotenuse. So these are the trig ratios that I'm referring to. So those are the ones that I need you to use. So the sine is opposite over hypotenuse, and we have the cos. What is the cos equals to? This will give us the cos, which is the cos of x is equals to cos is adjacent all over hypotenuse, and then we have the tan. These are the ones that you need to use if we are working with a right angle triangle. Okay, so now the tan of x is opposite all over hypotenuse. Né? Opposite all over opposite all over adjacent. Right. So these are the ones that we need to use. So now when you need to prove something in a non-right angle triangle, always use sine, and then I'm just giving you the tips now. These are the things that you need to understand in order for you to master the three-dimensional. Listen, if you are working on a proof, if they want you to do proof, when you need to prove something, let's say that you need to prove something. Look at this. This is what you need to do. If you need to prove something in a non-right angle, so if you need to prove something in a non-right angle triangle, so a non-right angled triangle, you can always use the sine rule. It's always use the sine rule. Now I need you to use cos. You can use cos if the cos rule, if you need a square root. If you need a square root, this everything will make sense. If you need a square root, or let's say you need something that should be inside the bracket squared, then that's when you can use the cosine rule. Don't worry guys, we'll start working on examples now. We'll start working on example. As I've said, if you need to prove something in a non-right angle triangle, what do we use? we use the sine rule, and you can use the cos rule if you need a square root. So let's try to work on this now. Let's say that I have a non-right triangle like this. Let's say this is my triangle here. Okay, let's say this is my triangle like this. Right, so this is point E. I'm not sure what's going on. Okay, let's say this is point E. Nah. I'm just gonna call this E here. Okay, let's call this point D. So I'm not sure what's going on. I see solids here. Let's call this D. Let's call this B. So I have triangle BDE. So in this triangle BDE, let's say the length from B to D, it's 7.1 kilometer. 7.1 kilometer, or we can say meter, but it's fine, kilometer. And then let's say I have the length from B to D. Let's say this is given as 5 kilometer. Right. So now, if this, let's say, let's just put some angles there so that we can be able to work on this. Let's say this angle here, this is my 38 degrees. I'm not sure what's the issue with this, but it's fine. So let's say this is my 38, and then let's say this angle will be 29 degrees. Come on, guys, what's wrong? Okay, so I'm trying to show you guys how to bring this angle inside the triangle that you are currently working on. Next, I'm trying to do that. So now, what I'm going to do, look at this now. Let's do this. We're going to say from this information, let's find, we're going to calculate the following. Number A, let's start calculating. Let's start by calculating the length of, maybe we can find ED. Number 1. Guys. Okay, let's calculate length of ED. So in order for us to calculate the length of ED, look at where it's ED. Look at this ED now. We need to choose what are we going to use to calculate that ED. We need to look at this problem, like this is my line that I need to calculate, which is my ED. So I have two sides. I have EB and BD. So I'm going to use, I think it's best if we use, what can we use here? The cosine rule. Now we can use the cosine rule. Why can we use the cosine rule? Let's go back to the notes so that everyone can remember this. So on the notes, we said that we can use the cosine rule if we have two sides, if you have two sides and an included angle. Look at the question. I have two sides. I have this side and I have that side. I can find my included angle. How can I find that B? Because to use the cosine rule, we need angle B. So this is what I'm going to do. First thing first, I need to find angle B. So I need to find that angle B. What will that angle be equals to? So this will be 180 degrees. I'm going to subtract 29 degrees, and we also have to subtract 38 degrees. then you're going to give them a reason and say the reason for this is because these are angles on a straight line. So that will be your reason. So this will be angles on a straight line. Angles on a straight line. Okay, I'm sorry about that. Therefore, what is angle B equals to? Thank you very much, Ntombizota. So Ntombizota got the answer as 113 degrees. So I'm just going to substitute this as 113 degrees. So when it's like this, we can quickly do what? We can just find this using the cosine rule. Now, the cosine rule, remember we said the formula for cosine rule is a squared plus, it's a squared, it's equals to, so this will be a squared, and we're going to say the a squared is equals to b squared plus c squared minus 2bc, and the sine of what? We are using the cosine rule, so it will be the cos of that included angle. Okay, so now if we need to apply the area rule here, this is what we need to do. Look at this. We have the included angle, which is b. This tells you that you need to find for the missing side, which is AD. We're going to use small b. So my A now becomes small b, which is my ED. So this will be ED squared is equal to b squared plus c squared. Those are the included angles sides. So this will be EB, which needs to be squared. We're going to add BD, which will also be squared, minus 2 of that EB multiplied by what? By BD. Then this will be the cos of that included angle. Remember we said the included angle is the angle that is between the two given sides. So this will be my angle B. So everything here is going to be easy when we have it like this. We can say that my ED squared is equals to EB. It's given as 7.1. So I'm just going to substitute this as 7.1, and this should be squared. We add BD. Let's look at this. What is BD? 5. I'm going to say this is 5 squared minus 2, and I have EB as 7.1, which is multiplied by 5, the cos of that angle B, which was 113 degrees. So we can say that ED squared is equals to, you just have to punch everything there on the calculator. You just have to put it on the calculator and see what you get. So when you put that on the calculator, whatever that you get, you're going to say square both sides. Ne? Why are we so serious? Why so serious? Thank you for joining in. Ne? And then now when we punch this on the calculator, what do you guys get on your side? 7.1. This is squared plus into 5 squared minus 2 into 7.1. Guys, you already solved the problem. You guys already squared both sides. It's 103. Oh, you guys, am I moving that slow? You guys already got your answer. Is fine. Let me square both sides now. I square both sides, therefore my ED is equals to 10.16. Thank you guys. So this will be 10.16 kilometer. Thank you guys for that. Né? That is very correct. So let's say now we need to find, let's say they ask you, okay, maybe I'm moving slow. Né? Let's say they ask you to find angle D. Let's calculate angle D. Now that we are looking for angle D, the best thing that I can do is to use the sine rule. So now I'm going to teach you how to apply that sine rule formula. I know that you, I think everyone realized that when we start, most of the time we start with a homework question. Then the more we push, the more we're going to work on more complex problems. Now, look at this. Look at this. They want us to find the angle of D, and I'm going to use the sine rule. So look at this. We can say that the sine of, we are looking for angle D, so it should be on our formula. The sine of angle D all over small d, it's equals to, now I'm going to choose the side that has, how can we say this? The side that has the angle opposite to it. For example, look at this angle B. We have 113, so we don't have a choice but to only use that AD. So we're going to have the sine of, on top we're going to have the sine of angle B all over small b. We can't use the sine of angle E because we don't have the angle E. We can't use this one. I hope everyone understands that part. We can't use that one because we don't have that angle E. So now the next thing that we can do from this point, okay, so the next thing, okay, so now what we're going to do now is that we're going to substitute. We know that sine angle D, look at this, sine angle D, what is that equals to? It's what we are looking for. And the side that is opposite to that one, it's what? 7.1, ne? 7.1. Please give me a second, guys. Okay, so now look at this. Let's work on it. Let's see what we get now. I have this. I'm just gonna say this is the sine of angle D on top. Everything is divided by small d, which is 7.1. I'm going to equate this to sine B, which is the sine of 113 degrees. Equate this by B, which is ED, the one that we just calculated, the 10.16. So this is my 10.16. So when it's like this, what else can we do from here? We just have to cross multiply. Now, when we cross multiply, I'm going to say I have 10.16 the sine of angle D, and then let's equate this to the 7.1, the sine of 113 degrees. Right. What I'm going to do, I can divide both sides by 10.16, divide this by the 10.16. Therefore, I'll have the sine of that angle D to be equals to 7.1, the sine 113 degrees. Everything is divided by 10.16. Guys, I need to see your questions. I need you guys to ask questions, okay? So therefore, to find this thing, you just have to punch this on the calculator and tell me what you get. If you have 7.1 sine 113 and everything is divided by 10.6, what is your answer? What do you get on your side? So we have the 7.1 that we need. Okay, 0.64. I'm just gonna trust you with Tepo. I'm just gonna say this is equals to 0.64, but remember, you don't have to round off that answer yet. Just say what you're going to do is say D is equal to the sine inverse. Don't say 0.64 on your answer. I need you to say the sine inverse of answer. Just write answer, né? Then whatever that you get is your angle D. And what is angle D equals to? What is that equals to? $39.79. 40.4. With Tepo, you see you rounded off your answer. So if you round it off, then you're going to get 0. I mean, you're going to have problems, ne? Please don't round off your answer. So I'm just going to take the 40.04. So 40.04. Please don't say the sine inverse of 0.64. Say the sine inverse of answer. Or the best thing that you can do, listen to this, ne? The best thing that you can do, you can write this thing in this form. You can just solve this in this form and say, just to avoid rounding your answer, you can say that Angle D is equal to the sine inverse of that 7.1 sine 113 degrees, and everything is divided by 10.16. Okay, Bitsapo, you can put it like that and you should get your angle D to be 40.04. Right, so now that I've introduced you guys to I know that you already know these things. This was just a home-up. Now let's work on exam type questions. Okay, Bitsepo. So now let's work on exam type questions. Né? So in an exam, you're going to get a problem like this. Let me quickly put the drawing on the board. You'll get something like this in an exam. Let's say they give you a triangle. Now I'm just gonna put my triangle here. Okay, let me put my triangle here. Okay, so on this triangle we're going to have something like this. Né? Okay, this is my 90 degrees, this is my 90 degrees. Okay, this is what I have so far, and then this is T, this is going to be your T, and this is going to be your B. Make sure that you understand the drawing there, and this will be my right. So this will be my A. Right, so that is my A. I'm just gonna name my angles using a different marker. So now when I name, okay, thank you, I got it. Joshua Vitepo. So now look at this now. This is my H, this line here. This line here is my H. And then what else do we have? This angle here. This is your X. I'm just gonna close that angle because it's your X. And then what else? Let's say this angle A here is your 2x. Let's say which is also equal to this one, which is 2x. Right. So from this information, we're going to answer the following questions. Né? I hope everyone understands that diagram. Maybe we should also try. So you guys can see the difference. We have this triangle, it's like this. So that everyone can see what is going on here. Next, so let's answer the following questions. Let's answer the following question. Number one, let's write, they always like to ask this in an exam. Né? Write AB in terms of X and H. So ladies and gents, if they say you need to write AB in terms of X and H, please note that they are trying to tell you that your answer should have both X and H. You need to have that on your answer. So when they want you to find AB, you're going to check in which triangle it's AB. Where do we have AB? Okay, so now I know that AB is in triangle ABT, and it's also in triangle ABC. So can you see that AB is a common line between triangle ABT and triangle ABC. I hope this makes sense. The line that they are referring to, it is this line. This is the line that they want us to do, to calculate. So what I need you to do, I need you to first focus on what? I need you to first, unfortunately I don't think we're going to have much time like to go through like the, what is this? I'm not sure if we're going to have much time to go through and maybe separate the triangles, but I'll try to do that. Né? I'll try to do that. So if I say in triangle, triangle A B T. So look at triangle ABT. I'm not sure if you guys, maybe we should just draw triangle ABT, but we're going to waste time. Just focus on triangle ABT. Let me highlight this in the like this. This is my triangle ABT. Look at that triangle ABT. So the triangle ABT is like this. This is your B. This is your okay. Okay, this is my 90 degrees, this is my A, this is my B, this is my T. The reason I'm rewriting the triangle, I just want to make sure that we don't leave anyone behind. Né? So I can see we have a comment from R. He's saying H cos or sine, H cos or sine. Let's see. This is H, and then we are looking for AB. We don't have AB. This is what we are looking for. Né? So now look at this. This is a right angle. Why are you sending so many comments? R, what's wrong? I can see your comments. Né? I just want to see what you are trying to say when you say H cos X over sine X. Okay, let's see if you are trying to give us the answer or what. Né? So listen guys, when I have this type of question, I'm going to say that I'm looking for AB, which is my adjacent, and I have my opposite. So I'll consult the SOHCAHTOA so that I can know that which trig ratio I need to use. So look at this. We need the one that has A and O, which is tan. Then I'm going to write it down and say the tan of what? This angle here is given as X. So the angle is given as X. This will be the tan of X. It's equals to, according to SOHCAHTOA, its opposite, which is H, all over adjacent, which is what? AB, the length that you are looking for. This is AB. Yes, thank you very much. Thus, I can see, but I did fix the angle. So now I can see that they wanted us to write this in terms of X and H. So we both have X and H. Let us make what? Let us make AB subject of the formula. I'm just going to work out this problem to make AB subject of the formula. Look at what I'm going to do. I'm going to say I have the tan of guys, I'm not sure if I can find my other SP pen because this one is not doing good. So tan X is equals to H over AB. Let's multiply both sides by AB to get rid of that AB, okay? I hope everyone is with me on that. The AB will cancel. This side I'm left with AB, the tan of X, which is equals to H. But we are looking for AB. We can just divide both sides by what? The tan X divided by the tan of X. Therefore, what is AB equals to? When we solve this, the tan X cancels, then we'll have H over tan X as your final answer. So I think it's very important that we highlight that. We might need to use it in the next lesson, in the next question. We might need to use that in the next question. Yeah. So the next question says that we need to prove, let's use the same given triangle. I'm not sure if we will be able to work this thing out here, but let's start this on the new. I'll bring the triangle down, don't worry. So we need to prove that the area of triangle ABC, the area of triangle ABC is equals to h squared, the cos 2x, and everything is divided by 2, the tan x. This is what they want us to prove. Okay, so you know what I'm going to do? I think it's best if we bring down the triangle so that we can know what we are working on next. Let's bring down the triangle, and this is type of questions that most of learners struggle to answer. Eh? So look at this. If I bring down my triangle like this was the given triangle, and we had something like this inside. Okay, so this is my triangle. This is 90, that is 90. So now on this triangle we are given this as A, this is my B, this is my C, and we have this as T. So remember, this was given as H, and then so far this angle here, let's go and write those angles. Né? This is X, this is 2x, this is 2x, that angle there is 2x. So this is the information that we have so far, and they want us to find the area. So now look at this. If I write the formula for area, let's look at what they are looking for. They are looking for the area of ABC. So if I use the area rule, I'm going to say that the area of triangle ABC, it's equals to half. Look at this. We need to check which one is the included angle. It's angle A. So we need to use this side. Guys, I'm not sure if you guys can give me a second so that I can get my other SP pen. This one is not doing good at all. Okay. So now, remember we said we need two sides to be included. Né? I'm just going to try and highlight which side we are referring to. The two sides that are included, this will be this side and that side. Those are the sides that we need to multiply, and we're going to use the angle that is between those two sides. So this will be small, let's do this. I'm sorry guys. It's going to be small b. The opposite of this angle, it's going to be small b. We're going to multiply that by the opposite side of this angle, which is small c. So it's going to be times bc, and then this will be what? This will be the sine of that included angle, which is angle A. So this tells you that we need to find small b and small c. So we know, remember we just calculated our AB, the line of AB. So if we do the substitution, the area will be 1 over 2. Small b, look at this. Small b, it's AC. I'm not sure if you guys can see that, but small b, it's AC, multiplied by small c, it's AB, and then the sine of angle A. This is the formula that we're going to use to find the area of triangle ABC. Those are the sides. So now we have AB. Remember previously we just proved that AB is equal to this. That was AB. So we know what is AB. I'm just going to write it down here. Just going to say we find that AB was equals to h over the tan x. So what's next? We need to find AC. That's the only thing we need to do in this problem. Let us highlight where is AC. So this is my AC that we are looking for. We need to find that AC. We need to find AC. So if you check, I'm just going to start by using the triangle ACT. That's the triangle I'm going to work on. I'm going to say in triangle ACT, in triangle ACT, we have AC and we have the opposite side, which is this one. So I think maybe it will be easy if we can just bring the triangle down. This is what we have in triangle ACT. We have this as 2x, we have this as 90, this is my A, this is my C, and I have this as T. So we have the opposite and we are looking for the adjacent. Which one are we going to use? According to the SOHCAHTOA, we're going to use tan. So now I'm going to say the tan of that angle 2x is equal to opposite, which is h all over adjacent. This will give AC. The aim is to find what? The aim is to find what is AC equals to. So now if we rearrange this, remember I can just multiply this side by AC. I can multiply the other side by AC. Therefore, AC, the tan of 2x, what is this equals to? Is just h. But we are looking for AC. We can divide both sides by tan 2x to get AC to be equals to h over the tan 2x. Look at this. AB and AC are equal. AB and AC are equal. So now we just have to take these two given angle. Thank you very much, Malaysia one. I'm not sure if I'm saying this right. Thank you very much. So your answer is correct. So this is the ones that we need to substitute on our equation. We need to substitute these two guys. Okay, so now remember I'm just gonna rewrite this formula down. I'm just gonna bring the formula down. So in the formula I'm going to say that the area of that triangle ABC, it equals to, we said the area will be AC times AB, the sine A. So this will be half of AC times AB, the sine of, what was the angle? The sine of A. Okay, let's quickly do the substitution now. I do like to use different markers. I'm just enjoying this now. Okay, so this is equals to half. Then AC, we just know that this is h over the tan 2x. Close the bracket. AB is also h over the tan 2x. Close the bracket. The sine of A, what was A equals to? The sine of A is 2x. Now the sine of A, which is sine 2x. Guys, please remember we are trying to prove that the area is h squared, the cos 2x over 2 tan x. So this tells you that you need to understand how to prove the identity. So this is the identity that we have, and this is the identity that we need to prove. So you know what I'm going to do first? Let me row multiply. The top part will give me h squared. Please pay attention. Remember the sine 2x is over 1. So I need to multiply all my numerators. This will give me the top part as h squared, the sine of 2x. If we multiply everything on top, now we need to multiply all our denominators. This will give us 2 the tan 2x multiplied by the tan 2x. Okay, so and AB h over tan x. Let's go and verify AB. What is AB equals to? Yes, AB is tan x. Thank you very much, Mali. I'm just gonna call you Mali, ne? Thank you very much. So AB is just tan x, not 2x, ne? So AB will be just the tan of x. So I'm just gonna remove this there and remove that too. Okay, thank you very much. I really appreciate that, ne? Thank you very much. You just saved us, ne? You just saved us because we were going to be lost. Okay, so from this now we can try and do what? We can just try and solve this. So let me just rewrite the equation and say, okay, let's work this thing out. Let's try and simplify and see if we get what they are looking for. This will be the sine 2x. We know that if this is the sine 2x, we can divide this by 2. I'm going to change the tan 2x into the sine 2x over the cos 2x. Then I'm going to leave this tan x. Let me explain why am I changing the one with the angle 2x. Why am I leaving the one with angle x? Look at this. We need this on our answer. The tan x, we need it on our answer. We need that on our final answer. So there's no need for you to change it. So just leave it like that. Né? So when you have it like this, now we can just try to work out this this bracket thing. Né? We can just try to work it out. So what we're going to do, we can rearrange the top part as, let's rewrite the top part instead and say this is h squared, the sine of 2x, and everything is divided by, and then now when I multiply this thing, I'm going to say I multiply the top part. Remember, this is over 1, this is over 1. So the top part will give me 2 sine 2x, the tan x, and everything is divided by what? By the cos of 2x. So this is what I have. I can change the division into multiplication, but when you change the division, you need to pay attention to this part here, because this is where we have the division. So we can write the top part, we can write the top part and say this is h squared. Okay, let's bring this down. It's h squared to the sine of 2x. We need to divide this by 1. Then we change the division into multiplication. This tells you that the cos 2x will come on top, and then divide this by what? 2 the sine 2x times the tan x. So look at this. If we go back up, what are we looking for on top? We need h squared to the cos 2x, and on bottom we need 2 the tan x. Okay, so I'm just gonna try and analyze how can I get this. I know that on top already I have the h2, so I need to, if I row multiply this, let's row multiply first. So I'll have the h squared, the sine 2x, multiplied by the cos 2x. Everything is divided by our 2 the sine 2x, the tan of x. Now let's cancel the like terms. Then if we cancel the like term, we should have our final answer. Let's see what we get there. This and that cancels. So we can see that we've managed to prove the area that they are looking for. Therefore, this is h squared the cos 2x everything divided by 2 the tan of x. I hope this makes sense, ne? Yeah, I hope this makes sense. So let me just see if we have any questions, ne? Do you guys have any questions based on this one? Do you guys understand what happened here? Are you all happy? Say, are we going to get these notes? Yes, I'll definitely put the notes of I'll definitely put the notes on the group, ne? Don't worry, you will get the notes. You will get the notes, ne? I think this was easy. You can just go through the notes when I put them on the group. Then if you have any questions, you can just reach out and I'll try to explain those questions, ne? Okay, let's try another example, okay? Maybe we can call this example 2, it's fine. Sure, essay student. So look at this. When I say join the program, this is what I'm referring to now. Because remember, there's only how many days left? There's tomorrow is Friday, and then we have Saturday, which is the last day of the month. Then from Sunday, no, I'm not working on that this coming Sunday. So now the program is going to start on Monday morning for rewriting students. So now this tells you that I'll be posting last link on the group. So it's very important that you join the program, né? It's very important that you join the program because my focus will be on those learners who are on the program. Maybe for this live we can just go maybe on during the weekends. Yeah, maybe during the weekend on Sundays morning, just for 1 hour. You see, we're going to continue with these lessons, but once a week. Yeah, so this is what you'll be missing. Look at this. Let me give you this triangle. Let's try to work on this one, né? Let's try to work on this. So if this is the triangle, if the triangle is given like this, and then let's say we have another triangle moving in this direction, right? So if I call this B, and let's say this is my D, I have C here, A, and then it is given that this line here is equals to that line, and then this is X. So if AC is X, you need to pay attention that BC it will also be X. But you are in an exam, they won't make things easy for you. They won't write X here. They just want you to see the lines that indicate that these two are equal. That's what you need to pay attention on. Hey, Tyson, you coming in and out, ne? Right. So if this is X, this is what we have so far. This is the information that we have so far. And then I'm just going to put the given angle. This one is alpha here. And then I have this as beta. This angle here as beta. Maybe we should just move it this side so that everyone can see that this is beta. Okay, that angle there is your beta. And then let's remove this one. All right. From this triangle, I have this length here as h. So I'm going to have this as my h. So this is my h. This is the information that we have. And we need to calculate the length of h. Calculate The question says calculate if it is given alpha to be 59 degrees, beta 48, and x as 4.38 meters. First thing first, the first thing that you need to do, you're going to say, they want us to find the length of h. They want us to find this h here. So how can we find h? Because you know what I'm going to do? Now I know that when I need h, I need to bring what? Something, beta and x in there, in this triangle. I need to bring them in this triangle. So now this tells you that the only way that we can bring them is to find the length of AB, because I know that the length of AB will have like beta and also x. That's what we're going to do. We need to find that thing, or we need to bring AB also in the party. First thing first, look at what they are looking for, h. So if you can derive the formula to calculate h, you are good. So in that triangle, this will be my adjacent, this will be my opposite. So this tells you that we need to use the tan of alpha, which will be opposite, it's h, all over your adjacent, which is AB. So now we can just multiply this side by AB, multiply the other side by AB. Therefore we have AB, the tan of alpha, and what is this equals to? H. We need to make AB subject of the formula, divide both sides by the tan alpha, then you'll get your AB to be h over the tan of that alpha. Wait, did we do this right? We are looking for h, guys. We are not looking for AB. Let's fix this, né? Let's fix this. We are looking for h. We are not looking for AB. So I'm just going to leave that equation there. I'm just going to leave this equation. Let's call this equation 1. So h is just AB, the tan of theta. I'm sorry, the tan alpha. This is my equation 1. We are saying that we have h, which is equals to AB, the tan of alpha, and I'm gonna equate this as equation 1. So now from this, what is this telling you? What is this telling you? This simply means that we need to do what? This tells you that we need to find AB. Look at where's AB. It is in triangle ABC. Okay, so look at this. Look at what I'm going to do now. I have beta, and if I have beta, this tells me that this angle also, this angle will be beta, this angle there will be beta. So I'm just going to write it down here and say we have a lot of problems today, ne? A angle B C. This angle is beta. Reason angle opposite equal side. So my reason for this will be angles opposite equal side. Why am I saying like that? Because they said this is equal to that. So these two angles will be equal. If we have that, it will be easy for us to find angle C. We know that angle C will be 180 degrees. We minus, what are we going to minus? Beta minus beta. It's the reason for this is interior angles. This will be interior angles of a triangle, because they end up to 180. So what is angle C equals to? What do you get as angle C? Angle C will be just 180 with minus 2 beta, because those are the like terms. So that is angle C. So now I'm happy I have angle C and I also have angle ABC. Okay, so now I can start working on that triangle. I can start finding AB, because we are looking for AB. If we are looking for AB, which angle are we? I'm just going to write this down first. So we are looking for AB over the angle that is opposite to AB. It's angle C. So this will be the sine of C. And I need to equate this to, I'm just going to use any sides between AC and BC, because both of them, the sides are given. We know that both of them is just x. Ne? So I can use any sides. Maybe I can use sine of that beta. So I can say this is equals to let's say the length x. We can use any, and then the sine of that beta, because it doesn't matter which side we use. These two sides are equal. We know that even if we use this one, we still get x over the sine of beta. So now I just have to substitute what I have. I'm going to write this and say this is my AB over the sine of, look at what is angle C. We just said angle C is 180 degrees minus 2 beta. Then let's equate this to x over the sine of beta. We are looking for AB, but before we do that, remember we need to do the reduction formula. So you see why it is important that you understand how to do the reduction formula. So now what I'm going to do, I'm going to do the reduction formula. Then I can write this equation as, I'm going to check in which quadrant do we have the sine of 180 minus theta. That is quadrant 2. Ne? It's in quadrant 2. We can write this as AB over, how is sine in quadrant 2? Sine is positive. This will change into the sine of 2 beta, which is equated to x. Thank you. Thank you for your answer. I can see that, over the sine of beta. Now we need to make AB subject of the formula. We can just cross multiply and say AB, the sine of beta, is equals to x, the sine of 2 beta. Right. So what I can do next, I can just divide both sides by sine beta. Sine is positive. Thank you very much. Ne? So AB, what is AB? What will AB be equals to? AB will be equals to x, the sine of 2 beta, and everything divided by the sine of beta. So now we know what is AB equals to. We know what is AB equals to. But now let's try by all means to do what? To simplify this third. I think we can work on this. I think we can simplify this thing. I'm positive about this. Now let's try and simplify this. AB is equals to the top part. I know that this is a double angle for for sine. So I know that the sine of 2 theta can be written as 2 the sine theta the cos of theta. So I can say this is x, the sine, okay, it will be x2, so this will be x, okay, I'm still trying to erase this s. Okay, so this will be 2, we can substitute this guy here, the sine 2 beta, ne? Let's substitute this as, this will be multiplied by 2, the sine beta, the cos beta. And everything is divided by that sine beta. So now, what is AB equals to if the sine beta cancels? So AB, it will be x, let's call this 2x, the cos of beta. I think now this makes sense. Now, remember we are looking for h, and we know that h is AB, the tan of theta, ne? So we're going to call this equation 2. We're going to call this equation 2 so that we can sub in equation 2 into equation 1. Say I'm lost, please explain after what. Which part you don't understand, Tomizoto? Which part? You lost? Which part do you want me to explain again? Which part you don't understand after the first formula? Okay, so this is my first formula, right? This is my first formula, and now on the first formula we know that we need to look for AB. We need to look for AB according to the first formula. So we're going to check in which triangle it's AB, and I can see that this is my AB that I'm looking for, and I need to bring beta and x into the party. So this is the triangle that I should work on. So on that triangle, I'm going to focus on what? I'm going to focus on finding. I need to bring beta and x, or whatever that we're going to work on. So now, AB, it will be the sine of angle C, because angle C is the one that is opposite to that AB. That's why we had AB all over the sine of angle C. Then this is equals to x over the sine of B. So once you can find this part here, you just have to substitute what you are given. The sine of angle C, remember, we calculated angle C as what? We calculated angle C as 180 minus 2 beta. So where there's angle C, I just substituted 180 minus 2 beta. Then now I need to do the reduction formula. This is the reduction formula. Here we applied the reduction formula. This changes into where it's 180 minus theta, quadrant 2. How is sine positive? This changes into positive, the sine of 2 beta. That's why we have the sine of 2 beta. Then in this step, we just have to cross multiply. We take the A, we multiply this with the sine beta, and we take the sine 2 beta, we multiply with x. This is what we have. Then divide both sides by the sine beta to make AB subject of the formula. So when you have it like this, we just have to simplify this guy here, because this is your double angle. We need to double angle for sine, which we can put it as 2 sine theta the cos theta. Now the sine beta and the sine beta cancels. We are left with 2x, the cos of beta. So we know what is AB. We need to go back to the equation 1 where there's AB. We need to put that. Remember that equation 1 was given as, guys, we don't have a space now. Equation 1 was given as What was equation 1? It was h, it's equals to AB, the tan of x. So where there's AB, we need to put this as 2x, the cos of beta, multiplied by the tan x. So this is what h is equals to 2x, the cos of beta, which is my AB, multiplied by the tan x. I hope everyone is happy with that, ne? I hope everyone is happy with that. Then, now, when I have this, I can just find the length of h. Because remember, we know what is x, we know what is beta, we know what is alpha. Alpha was 59, beta was given as 48, and I'm sorry guys about that. So beta is 48, we have x as 4.38, and we have alpha as 59. I just have to, show them Tomizotwa. Okay, everyone is happy now, ne? You guys were lost. Okay, so this will be 2, where there's x, I need to put 4.38. Then this will be the cos of beta, which was given as 48, and the tan of 59. I think the only mistake that we are making here is to call tan x instead of alpha. This should be alpha. It was tan alpha. This was alpha. So this should be alpha. Now if you go back, it's alpha. It's tan alpha, not x. Now. So now alpha was given as, what was alpha equals to? 59. So where there's this, I'm just going to put 59 degrees. And that's it. Whatever that you get on your calculator, it's your h. You just have to punch this on the calculator, and you get that this is 9.76 meters. Okay, thank you guys. Do you guys have any question based on this one? Okay, I guess everyone is happy now. So look at this now. Let's say I want to work on, no say, thank you now. Let's say I have a diagram like this. The issue that we are currently having today is our SP pen. This is the only issue that we have. So now look at this now. I'm going to say if this what I'm given, I'm just gonna try and do a triangle here. I'm just gonna close that one, and then let's say this is my B, and let's say this is my C, and I have this as D. So if I have this as a 90 degrees, and then it's further given that this side is equals to that side, and now this is x. We know that if this is x, This angle will also be x, but we are coming to that one, and this one is given as 90 degrees plus 2x. Right, I hope everyone can see that now. And I have this angle here as x, so the length here will be 7 centimeter. Okay, so the length here will be 7 centimeters. So now look at this. Let's say the first question, number A, question 1, they want us to prove that AC is equals to 7 the sine x. I'm not going to waste any time on that one. I'm going to prove that AC is equals to, so point A is this one. We need to prove that AC is 7 the sine of x. Please don't waste time on that one. You just have to tell us which triangle you are currently working on. So if I give you the triangle, I'm going to say in triangle, what is this one? I'm going to say that in triangle ADC, ACD, ACD, what is going on in triangle ACD? I can say the sine of x, because I'm looking for x. So if I use this angle, which one is my adjacent? This will be my adjacent, this will be my opposite, this will be my hypotenuse. You need to be very careful when you choose your adjacent. It depends on the angle. This is my angle, so my adjacent will be AD. So if I'm looking for AC, I need to use opposite and what? And hypotenuse. It's opposite, so my AC this time it's opposite. Please don't say your AC adjacent, because AC is the one that is opposite to that side AC. So AC is opposite to angle x, so we're going to say the sine of that x, it will be equal to opposite, which is your AC, all over hypotenuse, which is 7. The next thing is to make AC subject of the formula. Divide this side by 7, divide the other side by 7, and this should just be 2 marks. What is AC equals to? AC is just 7 the sine of x. So now that we've answered the first question, we can move to the next question. Look at the next question. We need to prove that prove that area triangle ABC, it's equals to 24.5 the sine squared x minus 49 the sine to the power 4x. Okay, so when I have a problem like this now, and they want me to prove the area, I know that first thing first, I don't have to stress. I just have to write my formula for area down now. And the formula for area, I need to find area of ABC. So area of ABC. So the area of triangle ABC will be half. Then I will check what I have now. So I'm just going to use the half of B, C, the sine of A. Okay, let me explain why I chose this formula and why am I using B and why am I using, right. So I'm just going to use this depending on what I'm given now. Look at this. I need to use Remember we said angle A should be included. You'll go to your triangle ABC. You're going to look for the given side. Look at this. We know that AC and AB are equal. So if this AC, it was given at 7, the sine x. So this side here will be 7, the sine x, which also make AC to be 7, the sine x. We have two sides, so this will be my included angle. So that's why I'm going to say it's going to be the small c multiplied by the small b. That's why I'm choosing that angle. It's very important to know which formula you're going to use, which side are you going to use. Very, very important. Né? It's very, very important. So now, what we're going to do is that from this thing, we just have to substitute what we have on this formula. We know that b and c are equal because this is my small c, this is my small b. Both of them, they are 7 the sine x. I'm just going to put it on that formula and see what I have. This will give me 1 over 2 into 7 the sine x into 7 the sine x. Therefore, this is the sine of that angle A. Remember, what is the sine of angle A? 90 plus 2x. So I'm just going to put this as inside the bracket. What is this inside the bracket? Plus 2x. Jakey, welcome. Ompile, welcome. You just have to, you see, when you have it like this, you just have to work this thing out. Look at this. This will be half. 7 times 7 will give us 49. Ne? 7 times 7, I'm not sure if is that right? 7 times 7 is 49. Yes, that's 49. I'm going to have 49, the sine squared x, because I'm multiplying the brackets. Look at this, the sine of 90. This is a cofunction. Sine changes to cos, cos to sine. Where's 90 plus? It's in quadrant 2. How is sine? Sine is positive. This will change into positive, the cos of 2x. This is what we have so far. So now, the next thing that we need to do is to multiply out the bracket with 1 over 2, because if we multiply out the bracket with 1 over 2, we get that 24.5. So this will give me, remember this is 49, so this will give me 24.5 sine squared x, the cos of 2 alpha. So now this is an identity. Remember that. I need everyone to remember that the cos of 2 alpha, we can write the cos of 2 alpha. There are 3 identities that we can use. Né? We have 3 identities that we can use. So I just have to choose which one I need to substitute. So the cos 2 alpha is the cos squared x minus the sine squared x, and it's also equal to 2 the cos squared x minus 1, which is also equals to 1 minus 2 the sine squared x. So remember, when we choose the identity, we need to choose what do you see before or after the cos 2x. What do we see? We see sine x, so we need to only substitute the equation and the identity that has sine x. So the one that I'll go with is that one. So where there's this, I can write this as 24.5 the sine squared x. I can say inside the bracket this is 1 minus what? This is 1 minus 2 the sine squared x. Look at this. Are we close to the answer? Yes. We can just multiply out the answer by that 24.5 sine squared x. So this multiplied by that is just 24.5 the sine squared x. Therefore 24.5 multiplied by 2, which will give us negative 49 again, and we have sine squared times sine squared. The base are the same. We add the exponent, which will give us the sine to the power 4x. This was easy, né? This was easy. So what I need you guys to do is that when you see this type of questions, please don't panic. Just apply what you know. Caterpillar, I think you are late, né? This is where we're going to stop, guys, for today. I just want to talk with you guys before you leave the live. Let me quickly stop my, okay, let me just, this is where we're going to stop for today, ne?